In this slide, I will present you lecture 1. First, let's start with some concepts about electrical and computer engineering. Here we have some topic related to electrical and computer engineering. Um, about electrical engineering, we have a current, a voltage. We also learn about equivalent resistances, diodes, and a transistor. And for computer engineering, because the computer operates on a binary system, so first we will learn about what's the binary system. It means just 1 and 0. And we also learn about some basic logic gates such as AND gate, OR gate, NOT gate, and some basic logic block such as multiplexer and other, and so on. And in this course, we just focus on how we compute power and energy and equivalent resistances. We also learn about some basic circuit laws such as Ohm's law, and this law you already know that, and the Kirchhoff's law, and some method used to analyze the circuits, such as divided through IV characteristics, notch analysis, and Thevenin and Norton circuit, equivalent circuits. And for computer engineering, we just focus on digital circuit analysis by using a Pullen expression, a total, and timing diagram. Okay, the first basic electrical quantity we will learn is the current with symbol I in unit ampere. And you know that the current if there is an orderly movement of charged particles, and the charge with symbol Q in unit coulomb. And we have two kinds of charge, positively charged such as a proton or holen, and the negatively charged such as electron. And the modulus amount of charge is Q. Just for one electron, we have Q equal minus 1.6 times 10 power minus 19 coulomb. And note for one proton, the charge is minus Q, and this value greater than 0 because you know the proton is a positive charge. And normally one atom is electrically neutral because it has the same number of protons and electrons. Okay, we have some remarks here. Like charge repel each other and opposite charge attract each other. Okay, now we will learn about the direction of the current. By convention, the positive current is opposing a flow of electrons. Okay, let's look at the example. We have electrons are moving from the left to the right. It means we have a positive current I have direction from the right to the left. And it's the same in case a negative current I have the same direction with the flow of the electrons. Okay, look at example 1, what we have here. And you can see that the positive current is opposing the flow of a negative charge, and it has the same direction with the flow of a positive charge. Or we also say that the negative current has the same direction with the flow of a negative charge, and is opposing the flow of a positive charge. Okay. Let's do some exercise. Exercise 1. Show the direction of the chart below. A. We have 14 arms have direction from the left to the right. So in this case, the direction of the negative charge is opposite, okay, from right to left. B, we have 30 arms have direction from the right to the left. Therefore, the direction of the negative charge in this case is from left to the right, okay? And C, we have minus 8 arms have direction from the left to the right, and in this case the direction of chart have the same, okay, from the left to the right. Okay, last one. Okay, be careful. In this case we have positive charge. Be careful. We have a minus 12 arms have direction from the right to the left, and in this case the positive charge have direction is opposite, okay, left to the right. Okay, let's move on. Exercise 2. With the numerical value of current I1 and I2, if we have I with the values is 6 arm and the direction of I is the right to left, okay. Okay, we have I2 in the same direction. I saw I2 had a value is 6 arms, and I1 is opposite of I2, so the value of I1 is minus 8 arms, okay. Okay, exercise 3 with the value of current I. Okay, and in this case you can see that we have the open circuit here, and in open circuit we have no current. In other words, the value of I equals 0. Okay. Okay. Now we move on the next slide, and in this slide we will find the relationship between current and charge. A current is the rate of flow of electric charge, and it can be defined by the delta Q over delta T. And in other words, we can say that one arm equals one current per 1 second. Okay. Okay, let's look at symbol 2. In a wire, we have 10 power 20 electrons per second are moving to the right. And what is the sign of I and its magnitude? Okay, and this is a solution. We have a total charge movement per second is delta Q equals minus 1.6 times 10 power minus 19 times 10 power 20, because we have 10 power 20 electron, and the charge of 1 electron is minus 1.6 times 10 power minus 19. So we have total charge movement per second is minus 16 coulomb. It means we have I equals delta Q divided by delta T equals minus 16 coulomb divided by 1 second. So we have I equals minus 16 amps. Okay. Okay, let's talk about material electrical property. And in this slide, we learn about resistance. And resistance, the ability of conducting material to resist the flow of a charge or a flow of current. And you know that we have, if we have large resistance, it means we have the small current. Okay, and the resistance values given by the formula R equal flow times L divided by A. Flow means resistivity uh, in units ohm time m, and this value depends on the material. You can see example here. And L is the length of the conductor in meter, and A is the loss sectional area in the meter square. And notice the value of R increases, L increases, okay, and R decreases with the cross sectional area, okay. Okay, let's look at example 3a. We have circuit CA and the resistor R. The value of I is 3 amps. And what can you say about I1? The current through a resistor R. Okay, we have I1 equal 3 amps because I1 and I have the same direction. Okay, and in KB we have a circuit CB. A circuit CB on the left we have a current I1 equal 3 amps and resistor R1, and on the right we have the same circuit CB on the left, but we have different resistor R2. So the question is, what can you say about I2? Okay, if R2 equal R1, we have a current I2 equal I1 equal 3 amp. Okay, and in case R2 greater than R1, we have I2 less than I1. Okay, be careful. And if R2 less than R1, we have the value of I2 greater than I1. Okay. Okay, we have two exercise. Okay. And two exercise you try to solve them. Okay, we already have a solution here. Okay, now let's okay, that's enough for this lecture. Okay, see you on the next lecture.